Hey class, Mr. Houston here. Today we are combining a few lessons. We're taking Chapter 4, Lesson 4, and we're going to combine it with Lesson 5 and Lesson 6. The reason we're going to be doing that is because we have, it's all about the triangle congruent theorems. So we're just kind of going to throw them all together, talk about them, so that way you can prove triangles are congruent using any of these given postulates or theorems. So let's take a look at them. So instead of trying to prove triangles congruent by finding all of the corresponding sides and all the corresponding angles and making sure they're equal and all this other stuff, these are methods to shorten that process. There's, I believe, 5 of them that we're going to talk about today, and they're all ways, again, of shortening, figuring out if triangles are congruent or not by just some simple methods with usually about 3 items that you need in order to prove it. So the first one is a very simple one, and it's known as side, side, side. Now, I don't think I have to explain a whole lot about this. The only thing I'm going to point out is that all 3 sides of the triangle, or you have 3 sets of congruent sides. So notice these little tick marks here. Again, that means that side BC is congruent with side EF. AC, it's got 2 tick marks, so it goes with DF. And then AB with 3 tick marks is going to be with DE. So if we have 3 sets of congruent sides, then we can say that they are congruent by side, side, side. The next one is known as side, angle, side. Now, they name it this way specifically because the angle, has to be in between the 2 congruent sides. So if we take a look here, we have AC congruent with DF, and then we have AB congruent with DE. So when they use side, angle, side, you have a side, you need the angle that connects those 2 sides to be congruent to use side, angle, side. So in this case, angle A is congruent to angle D. So side, angle, side, the angle has to be in between those 2 sides. This one, HL, as we'll call it, only works for right triangles only. Okay? Right triangles only. And this stands for hypotenuse, leg. And just like all the other ones, they're pretty self-explanatory. So if I have a 90-degree angle, as we see here, all I need to know is if the hypotenuse is congruent on each, and if a leg is congruent on each. If I have that, then I can say they are congruent by hypotenuse, leg. So again, you're still looking for 3 pieces of information, but we're mostly concerned with the hypotenuse and the leg as long as we have those 90-degree angles. The next one, angle, side, angle. So it's kind of like side, angle, side, except the reverse of that. So we have angle B congruent to angle E, angle A congruent to angle D, and so because the S is in the middle, we want the side that is in common with both of those angles. So in this case, AB is congruent to DE. So angle, side, angle, 2 angles with the side included. Kind of skipped over that word, but when they say the included side or the included angle, meaning the angle that they have in common or that is in between them. The reason we're going to talk about that is because then we're going to take a look at angle, angle, side. Angle, angle, side is just like it sounds. We need an angle, but then I need a side that is not in between the 2 angles. So if I look at angle B and angle E, angle A and angle D, the one I can't have for this to be called would be AB and DE. That would be angle, side, angle. So if I have something other than the side that's included, and they say it down here, a non-included side, if I have something other than that, in this case AC and DF, then I have angle, angle, side. So angle, side, angle, the side is in between the 2 angles. Angle, angle, side is when the side is not in between the 2 angles. So those are the 5 that we were going to use to see if we can prove or determine if there's enough information to prove the triangles are congruent. If they are, then we're going to name that particular theorem. So really not much to go through. I gave you all the information up there. Now we're just going to see what we have, kind of label what we have, and then see if that's enough to prove the triangles are congruent. So number one, if you notice, I have a side congruent to a side, another side congruent to a side, and another side congruent to a side. So I have three sets of congruent angles. So number one, they are congruent. We would say yes, there is enough information, and that's by side, side, side. Okay? Now if we look at number two, we have a side and a side, side and a side, and then most people would stop right there and say, well, we just don't have enough information after that. Understand that when they share a side, the reflexive property says that it is equal to itself. So BD would be equal to BD, and that would give us our third side. So again, number two would be yes by side, side, side. Taking a look at number three, same sort of idea. Side, 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 side. They have that overlapping side, giving them a third congruent side, meaning that we have side, side, side. Okay, so let's take a look at the back page of this. Number four. Now we're going to get a little different here. So number four, we have a side and a side, an angle and an angle, and again, I encourage you to mark this, and we have another side. So we have, however you want to look at this, we have two sides and an angle not included. Okay, so anytime we have two sides with an angle not included, the answer to this is no. Okay, and we can joke about this. This is what me and Mr. Brooks like to call the donkey theorem. If you need some explanation on that, we can give you that in class. But there is no donkey theorem in this, so the answer to this is no. So let's take a look then at number 5. So the first key piece of information we always should look at is right here. We have that 90-degree angle. So if you remember, in order to prove something with a 90-degree angle, we need the H and the L, which is the hypotenuse and the leg. So if we look out here, we don't have the hypotenuse, but we do have two legs that are congruent to each other. So this side is congruent to this side is congruent to this side. Now, even though we don't have the hypotenuse, we do have both legs. So in a right triangle, if both legs are congruent, then we could do the Pythagorean theorem to figure out that this side is congruent to this side. So really, we do have it here. The answer would be yes, there is enough information, and you could either say it's by the hypotenuse leg theorem, or you could even say it's by side, side, side. Again, I don't like that they don't give you this information, but understand that if you have a right angle, you can use, remember, a squared plus b squared equals c squared. If we know that these are the same on both, which they are, then that means that the c squared would have to be the same for both. So that makes the hypotenuse the same on both sides. A little extra work, but you have to start seeing that. You have to start figuring out what information can you prove is enough. Okay? Alright, so let's take a look here at this one. So if I have a right angle here, that means I also have a right angle here. So we're going to look here, and we're going to look here, because we're looking for the hypotenuse. Now I have this hypotenuse marked, but it's marked with this side. This is not my hypotenuse on this triangle. So I'm going to just stop right there and just say this is a no. There's not enough information to prove that one. Okay? Alright, so take a look at 6 here. We have a side and a side, a side and a side, an angle and an angle. Again, this goes back to the one at the top of the page that we like to call the donkey theorem. There is no theorem with side, side, and an angle not included? So the answer to this is no, or not enough information. Okay, that angle has to be in between the two sides in order for us to prove that it is, they are congruent. So like for number 7, we have a side, we have a side, an angle, and an angle. And remember that this is congruent, so we have another side. So as I work my way around this triangle, I have a side, and an angle included, a side, and an angle included. So the answer to this is yes, by side, angle, side. Now they're also going to ask you to pull on some information that you learned in chapters 2 and 3 when we started talking about parallel lines. Okay, so if I look here, I have a side here and a side here. They don't give it to us, but we know that that's going to be congruent. So I have a second side. So in order for this to work, I either need a third side that is congruent, or I need the angles in between them to be congruent. So I need this right here to be congruent with this right here. There's no way of proving that those angles are congruent to each other, and there's no way of proving that these sides are congruent to each other. So because we don't know that, we are going to have to stop there and just say, no, not enough information today. All right, and then down here, number 10, we have an angle and an angle. We have another angle and another angle, and then we have a side. This is a side not included between them, and that is one of our options. So we are allowed to say that by angle, angle, side, these are congruent. Remember, angle, angle, side means that we had two angles and a side that's not connecting them. Okay? All right, last couple ones here, and then we'll get you working on some. Take a look here. Again, I suggest you label everything you have. So I have a side, a side, a side, a side, an angle, and an angle. This goes back to our infamous theorem that we don't have. So our answer here is no. And then lastly, let's take a look at this one. Angle, 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 angle. And you may not see it, but be aware that side is congruent. So we have an angle, angle here, angle there, the side included. So our final answer is yes, by angle, side, angle. Remember, that side has to be included, or as we like to say, in between the two angles. Okay? So again, these are the 5 theorems that we can use to shortcut for congruent triangles. There will be a few more that we'll talk about in the next lesson, but make sure you get very familiar with these and trying to find as much information as you can on these triangles. Okay? All right, so if you have any questions, bring them with you to class, and we will see you then.